All right. So next up we have David Lutterkort. As I see in his slide notes here, founder of OBS, which is an incredible tool, but with an incredibly difficult grammar rule set. Anyway, he'll be talking about Razor, a provisioning tool, and I'll leave to him to explain what it does exactly.
Thanks, Walter. Thanks, everybody, for coming. As I said, I'm David. I write provisioning software. And I've been with Puppet Labs for since May of last year, so about 9 months now. But even though I'm pretty new to Puppet Labs, I've been in the Puppet community for much longer. I ran across Puppet pretty early on, in late 2005 or so, and did a bunch of stuff on it, pushed it into Fedora, and I've been around it one way or another for a long time. And one of the things that came out of my exposure to config management through Puppet, because I'm not a sysadmin by background, I'm a developer. One of the things came out of it was Audius, and if you modify your config files still with set, grep, and awk, stop doing that right now and check out Audius. But this talk isn't about Audius, it's about Razor, about provisioning. Provisioning is one of these words that mean a lot of things to a lot of people, kind of like configuration or systems management. For purposes of this talk, what I mean when I talk about configuration and about provisioning is this sort of situation. You have a lot of machines and you need to get them to do something useful. Hopefully your machines aren't sitting in the backyard. Hopefully somebody's racked them and cabled them up and they're ready to go. But traditionally Puppet has had kind of a first mile problem when it comes to getting going. Because Puppet really only starts after you have enough stuff on your machines that you can run an agent on there. And Razor is a tool to kind of close that first mile gap. It's of course not the only tool to do that. There's a ton of tools out there to help you with Pixie provisioning. There's a ton of open source tools that do it. Each of the big management packages has some provisioning functionality. And there's, of course, I'm sure everybody in here has their favorite Perl script, the 1,000-line script that does everything anybody might ever want to do with Pixie provisioning. But if you look at them, they all, they kind of fall into two piles. One of them, they do too little, and the other one, they do too much. The tools that do too little are the ones that just stop once they've installed all the packages, that end when you have a kickstart file. Run through a kickstart file during your install, because you're not just installing for the hell of it. At some point, you need to manage that machine too. And so the other pile, the tools that do too much, they realize that that's a problem, and you need to do something to get more fine-grained management than just plonking packages down, and they grow all this config management functionality. But that's of course the wrong place for config management functionality, because your provisioning tools only involved at the very first time you build your machine, but you need config management on an ongoing basis. So Razor tries to be the Goldilocks of provisioning tools. Don't do too little, don't do too much, do just the right amount. And the way it does it is that it makes it very easy to, once the system has been built, to hand it off to a config management system for further maintenance. So the philosophy behind Razor is that you just install the bare minimum of whatever operating system you're installing, and then enroll it with Puppet or Chef or some other config management tool, and then do the actual personalization of the system with that. And since there's so many variations of provisioning tools out there, to get a better idea, I made up a little user survey. Unfortunately, I didn't have time to talk to any users, so I just made up the answers too. And so we've done a lot of software engineering research with that. That's how that happens. But to give a little prehistory about why Razor came about, or how it came about, and why it does what it does. It was started by two guys at EMC, they're now at VMware, Nick Weaver and Tom McSweeney. They launched it in the spring of 2012 at EMC World, and then in the fall of that year at PuppetCon, they announced that they would move maintenance of Razor over to Puppet Labs because it's a really good fit with Puppet. but also because they felt they didn't have the time and resources to really push it forward. And what's happened since then is that over the last 6 months or so, in the early summer, we took a look at where the code base was, the initial code base, and kind of lessons learned from people using it. One of the lessons was that it was really hard to get the initial code base installed and going, and of course to maintain it. And so we decided to rewrite the whole thing. And my talk is about the rewrite. At this point, the initial code base is legacy. If you have an installation for that, great, but nobody should be installing that code base. Use the rewritten code base. So one of the things that makes RHEL unique is that it deviates from kind of the general approach of these pixel provisioning tools that try to make you look at your machines as pets. These things that you know intimately well, and you have a personal relation to them, and you really care about them, right? When somebody comes, hey, build me a web server, database server, whatnot, you go down the data center and look at your 500 most favorite, most beloved servers and pick the one that is going to do what you need it to do and go back to the office, enter the MAC address into your provisioning tool, and then hopefully you've got a machine at some point. So RHEL kind of taking inspiration from how people use cloud and trying to move that a little bit into the bare metal world, or in the pixel provisioning world, wants to look at your machines more like cattle, as things that are largely interchangeable. They have different characteristics, but within each group, they're pretty much the same. Just like with cattle, you have dairy cattle and cows that you raise for meat and maybe for breeding or for showing off at some show. But within that group, within each group, all the milk cows are pretty much interchangeable. And the way RHEL does that is that when a system when RHEL first encounters a system, it puts it into what in RHEL lingo is called a microkernel. It's really just a small Linux image that boots on that machine, runs factor, and sends the facts back to the RHEL server. And because of that, your RHEL server is kind of has an inventory of the hardware that you have. And then later on, RHEL decides what should go on there based on policy that you've set up. And so in your policy, you talk about what should happen with machines that have this much RAM and these many cores and whatnot. And based on these policy and rules, RHEL then decides, this should get RHEL, or this is a node that should get ESX installed. As I said, the rewrite, we changed a few things around. One of the things is we use Postgres now as the database, just because Postgres is awesome. But the database with RHEL is not a huge concern. We're literally storing tens of kilobytes of data for each node, so you can do the math, how many nodes you would have to have before the database gets a respectable size. We also use Sinatra. The server is written in Ruby, and we use a Ruby web framework called Sinatra. And if you haven't encountered Sinatra, you can think of Sinatra as Rails after a very, very serious diet. It's a really nice framework to write a web service. And the one thing that's probably a little unusual, so far that's pretty standard web stack. We use TalkBox, which is kind of a plugin to JBoss that turns JBoss into a Ruby app server. I don't know how many of you have deployed Ruby apps, and before you know it, your simple application consists of like 10 daemons, a few web workers, and some background workers, and something that reads email. It's a nightmare to manage, right? Because now you get to babysit 10 different things and monitor them and all that. The nice thing about TalkBox is that it lets me as a developer do all these things, but it does it in one process. So as an admin, it's just watching this one process instead of this myriad of little things. Right, so the one thing that's missing from here, since I've been talking about PXE provisioning so much, is a little bit the need for PXE provisioning. What about DHCP? What about TFTP? And there, RHEL also deviates from a lot of the PXE provisioning tools that kind of naturally branch into managing all that for you. RHEL does not do that. We don't really care what you use for DHCP or TFTP, DNS mask. Oh, don't use DNS mask. DHCPD, what have you. All we need you to do is put 2 files onto your TFTP server and then set your machines to PXE boot, the usual thing. But once you've put those 2 files on there, one of them is the iPXE firmware, and the other one is a little script for iPXE that basically tells nodes, once they come up, go and talk to this other server over here, the Razor server. The genius of iPXE is that it gets you out of the TFTP malaise of where you can't really do anything, and lets you do all the booting via HTTP. And now we can write a web server that has interesting behavior, does useful things, just to boot machines. And so once you've got those 2 files set down, you don't ever have to touch them again. Everything happens on the server. In terms of topology, Razor has really 2 APIs. One is a public API that you can think of that as the management API. That's what you use to tell the server what the policy and rules and whatnot are. And then there's, on the other side, there's a kind of private API that nodes use to talk to the server while they're getting installed or while they're booting. And that private API really only comes into play for you if you decide to write your own custom installer to do useful things, because then you need to know how to get files from the server, how to tell the server to log something or the thing is that the public API, we have proper authentication around that. We use basic HTTP authentication, and we use a library called Shiro or Shiro underneath that makes it really easy to plug it into LDAP or a bunch of other things. So the public API is pretty well secured. The private API, just by its nature, you can't really secure, because there, when a node comes up and says, "Hey, I'm a machine that looks like this," we just have to believe it as node. So on the back end, you have to secure that network by physical means, like make it its own VLAN or just completely segregated from the rest of the network. I think for people who do PXE provisioning, that's nothing. How many of you actually do have to manage physical machines, PXE provisioning? When I started doing this, I would have never thought that there's that many hands, because everybody's talking about cloud. But I mean, it's still a real problem to do provisioning. Huh? Yes, that too. Yeah. I'll talk about that at the very end a little bit. Okay, and so the public API is kind of fairly garden variety REST API. The one wrinkle is because it's really icky usually to modify things over REST, and it gets really awkward. To change things, we have commands. So you issue a command to create a policy or modify a policy instead of doing weird gymnastics with representations of REST objects. But the objects you need on your server are kind of the ones that are on here. Policy is the most important thing that ties everything else together. You need a repository or multiple repositories. That's the bits that you eventually want to install on a machine. You can either just point the Razor server at an existing repository, like the Yum repo that you have sitting somewhere, or apt-get repo, or you can hand it an ISO and import it on the Razor server itself. That's what people usually do for like Windows and ESX installation. They just import an ISO into the server. Broker is kind of Razor's lingo for the thing that does the handoff to the config management system at the end. So there's a Puppet broker, there's a Puppet enterprise broker. Somebody in the community wrote Chef broker. We don't ship that, but somebody in the community actually wrote a broker that just sends a signal on an AMQP message bus for the internal infrastructure. So you can, with a setup, you can do much more than just hand off to a config management system. And I mean, broker, at the end of the day, it's a fancy word for a shell script. It's really, really not much more. Tags are named rules, essentially. The way Razor works is that when a node comes in, Razor goes through all the tags it has and the rules that are associated with them and checks whether those rules match that node. Whether your rule might say that it must have more than 8 cores and 16 gigs of RAM, and then you tag it as a medium big machine. And all the same policy also carries tags, and once the tags for policy and the tags on the node match, the policy matches and gets applied to that node. And tasks at the end, those are the actual things that do the installation, your kickstart scripts and all that. We actually for tasks we went through a bunch of naming gymnastics because we initially called them installers, but we want to do these things more than just installation. So eventually we settled on tasks after a few detours. And to write an installer or to write a task is actually, once you have the installation automated, so once you have a kickstart script and maybe a post-install shell script together, getting that onto your Razor server is a matter of writing 5 or 6 lines of metadata of what these files are. Out of the box, we have installers for these things on the right. So we have an installer for ESXi. That was one of the initial use cases that Nick and Tom had for Razor. They wanted to deploy ESXi, and that's a real joy if you haven't done that. They wanted to deploy that automatically. We also have installers, of course, for the various Linux flavors, RHEL, CentOS, Debian, Ubuntu. And then the thing I'm really excited about, which I didn't think we would get not that quickly, is we also have a Windows 8 installer now, which is, I don't know how many of you install Windows on a regular basis. It's fun. But yeah, we have, and by all accounts, I haven't tried it, but by all accounts, it actually works. And so you can use Razor to provision pretty much all the OSs you usually encounter in a data center. The installer itself is kind of a linear process. You can say, the first time we boot with this installer, you do this, and that's usually you download some kernel init.rd that is actually the installer, and then the second time we boot, we do something else, and the third time, and so on, until eventually you're done installing and the thing is just set to boot locally. From then on, you have the machine in production, and it just boots locally. You could, for example, write your own installer that as the very first step does some configuration of a RAID card, right? Boot into some special image that lets you modify RAID config with whatever tools you use. And then after that, boot into the real operating system installer. It would be a pretty easy thing to change. Okay. So everything is about nodes in Razor, right? Those are the machines that we really do all this for, and why we do that, because we need to put something on these machines. And from Razor's point of view, a node largely consists of those 4 things. We have a little bit of information about the hardware that IPMI sends us, MAC addresses, serial, I think. You don't get very much information out of IPMI just because these firmwares are pretty restricted in what we can tell you. We have facts, which is right now a standard run of factor, which includes block devices and how much memory and cores and stuff like that. Then a fairly recent and really interesting addition is metadata. You can associate just a bunch of key value pairs with a node. And what makes this really interesting is you can do that both through the API, so you can make a call and set some metadata key. But you can also do that from the installer, like the installer can call back, or you can of course read those in the installer and make decisions based on certain metadata tags. So if you're totally crazy, you could push your whatever partitioning you want to have on your machine into metadata on your node, and then the installer can pull it out and lay down your custom partitioning scheme. And then the last thing is state, which tells you whether the machine is installed, and that's right now the only thing, but we'll add more flags there about what the node is doing. And those 4 things are all accessible when you write rules. So the decisions about what gets provisioned, you can base them off all these pieces of data, which gives you a good amount of flexibility. Another recent addition that's not on the slide is that we also added IPMI support. So now you can use Razor to both enforce power state, say this thing should be off and keep it off and check that it's off every so often. You can reboot it and you can turn machines on or off, on and off. Right now it's kind of simple. Basically, we support as much IPMI as IPMI tool does, but we want to add support for other remote power management. And so just a few examples of what Razor can do for you. Of course, you can build machines with it and add to Puppet or some other config management systems like Chef. Your initial use case of building nodes and setting them up with vCenter, you can that's actually Puppet modules that help you do that. But Razor's well integrated with that. One of the things I find really cool is you can use it to provision OpenStack. Because at the end of the day, you'll just you use Razor to lay down a basic operating system, get the Puppet agent going on that machine, and then you use the OpenStack Puppet modules to actually turn your machine into a Nova compute node or Swift storage or what have you. And then something that we're taking kind of baby steps towards, but I think that's what where Razor will go in the longer term is something that manages the life cycle of your machines. One of the really important differences between kind of Puppet's notion of what a node is and Razor's notion of what a node is that Puppet thinks of a node as something that lives as long as the operating system is on there. If you take a machine and reinstall it, Puppet will think, oh, that's a brand new node that I've never seen before. Whereas Razor really follows the machine, the hardware itself. It's not confused by reinstalling things, so it does that. And so you can use Razor to build complex life cycles. But like one of the things that people seem to do quite a bit is when you decommission a box, do a secure wipe before you install something else on there. And that you can actually trigger just by setting metadata flags and writing rules in a somewhat clever way. Something where we need to do more to make it really smooth is updating BIOS. If you once you know that the BIOS on these machines need to be updated, it would be really cool if you could tell Razor do that, and then on the next scheduled reboot you update the BIOS. So you don't need to have a specific reboot schedule just to do the BIOS update. You might have a reboot machines every 2 weeks policy. So when it reboots, Razor would then make sure that it first boots the BIOS updater image, and then once that's done, it goes back to booting locally and running whatever is on the machine. Okay. I've got a few pointers here. I think we have a couple minutes for questions. If you have questions. If you have questions after the talk, like tomorrow or so, we have a mailing list, IRC channel, and so on. Don't hesitate to get in touch there. No, I mean, the thing that's kind of awkward is the flipping back and forth between I'm doing a BIOS update and so the thing is that Razor right now, once you've run an installer against it, considers the node installed, and that keeps it from going through the policy table again. And so we need a way to mark some of these tasks as non-destructive. Right? Actually installers are destructive, right? And you would never want to apply them to a node that is already installed. But some of those things are non-destructive, like a BIOS update, and you would want to distinguish between those two and allow applying the non-destructive stuff even to nodes that are installed. What do you mean? TPM brings back flashbacks to a previous life. I don't know. I want to go there, and I don't know how much people would actually want to use TPMs for that, or how much they're actually using it for anything. Sure, Intel would love that idea. Yeah, not explicit. So the initial implementation had a state machine, and then when we actually looked at the installers, which in the initial thing were called models, that people actually wrote, they were all linear processes. There was no real use of the state machinery. It just made things very complicated. And so one of the decisions we took with the rewrite was installers are just linear steps. You do step 1, you do step 2, you do step 3, but there's no branching and cycling and all that. But some of that we'll get back with the additional data we have about a node, and things like what I just said, that we to distinguish between an installed node and or between destructive tasks and non-destructive tasks, and allow non-destructive tasks against installed nodes. So behind that is probably implicitly a notion of lifecycle of the machine, but it's not really exposed, because I think that's just too hard for people to really make use of. Yes?
Since you talked about decommission, can it already have the response certificates and revoke certificates of the Puppet master?
We don't have, so can it revoke certificates and pull stuff out of the Puppet master? Out of the box, we don't have anything for that, but it's a matter of writing a shell script that actually does that and sticking that into an installer. So it would be a pretty easy exercise to do. Yes? I've heard about Ubuntu's Metal as a Service. I haven't really looked at how they do things. My understanding is that they push much more into a cloud-like mode of operation. I think Razer tries to be very careful to strike a balance between being fairly hardware-centric and fairly close to the way people are used to doing physical management, and the kind of cloud-like features. Because I think there's a gamut of these uses. I don't think you'll make everybody happy by giving them a Metal as a Service cloud tool. So because of that, I would expect that there's quite a few philosophical differences between Ubuntu's Maze and Razer. Yes, Steve? Is it better to do? Is it better to do that? So generally, I would say whatever you can do with Puppet, do with Puppet, because Puppet is the thing that worries about the ongoing maintenance and configuration changes of your boxes, and only do the things you absolutely have to do outside of Puppet in Razer. If it's something you need to do to even get an operating system on there, you do it with Razer, and everything else you do with Puppet. Yeah. And I mean, some platforms allow you to do that. On the running system, and others you actually have to put into a little special image. But I mean, if you can do it, Puppet. Yes. I haven't really thought about that. Yeah, so for starters, I hate the word microkernel because it's a misnomer. It's a small Linux image. That was another thing we changed from the initial cut, is that we moved it to Fedora. Right now we're using Fedora 19. The rationale behind that move is that we as Puppet Labs can't be in the business of hardware support. I mean, there's companies that do that, and they're way bigger than Puppet Labs. So the idea here is that eventually we'll move to like an enterprise Linux microkernel, so that if you have a support agreement with one of the enterprise Linux vendors, you go and talk to them if your microkernel bars because it doesn't like the network hardware. But right now it's Fedora 19. Yeah, I mean, I actually just noticed that OpenOffice very helpfully made these links pretty much illegible. The first one to the server repo is to Puppet Labs /razor-server, and that's where all the documentation lives to on the wiki for that Git repo. I try to keep everything there, and then the other repos are kind of offshoots, but all the documentation and most of the information is on that repo. Okay. Any more questions? Okay, thank you. Thanks for your interest.